Hey Nano fam, hey YouTube. I hope this works. First stream ever, so maybe there's things going wrong. Can you hear me? Maybe just write yes or something in chat. Yeah, I think this works. All right, so welcome to the first RS Nano stream, and today we are going to port a small little part of Nano to Rust, and I've searched the code for a small, simple class, and almost all of them are ported already. But I found one, and um, it is let me check. Yeah, the block population here. It's open already. So let me just switch here so I can see the chat. Yeah. Hi guys. Hey Dimitrios. Hey. So, um, so if you have any questions, just ask. Also, if you are interested in certain parts of Nano, just ask and we can have a look at them. Um, I'm still learning about Nano as I translate, so I won't be able to answer all of your questions, I think. But yeah, it's a process. Um, so for today, I thought we would port the backlog population class. It's, as I said, very small. And what it does is it starts a thread and then periodically um, it periodically loads accounts and just triggers the election scheduler for those accounts. And I think the idea is that stuck transactions will get processed eventually. So the problem is we don't have the election scheduler ported. So that makes this actually a bit more difficult than I hoped. But I think we can work around this. So the election scheduler is, or the whole election stuff is a complicated thing, and none of that is currently ported to Rust except for the votes. So my idea was to, because we only call the election scheduler.activate, that we would just call back into the C++ code for the election scheduler. And I don't know if this works because I've not done that before, but let's just find out together. Okay, so where do we start? Yeah, so I've two IDEs open. This one is CLion for the C++ code base, and the other one is Visual Studio Code with the Rust code in it. If you want to know how to clone and build the project, there's two videos already on my YouTube channel, so just refer to them. Yeah, so let's get started. So my idea was, yeah, as a first step to add a callback for the election scheduler. So we don't have the election scheduler in Rust. So let's start there and create a struct for the election scheduler. So the structure here is pretty simple still. We have ledger for the ledger code. We have core, we have hash, and so on. And we have store LMDB with the database implementation for LMDB, and store traits with the interfaces, in Rust they are called traits for the database. And Node. And Node is still containing a lot of different things that I haven't split up into sub-modules yet. So yeah, let's start here with the election scheduler. And that's the first question. Maybe in voting, I can move it to another module later. So let's add a new file here, and let's call it election scheduler. Oh, hi, Foss. Hey, how are you doing? So election scheduler rs. So we have to tell that we want to use this file. So we say, so we're just going to add it here, mod election scheduler, and this is like an include in C++. And this is now our empty file where we can put the code for the election scheduler. So let's create a struct election scheduler, and this will have a function. No, this will have a function activate, was it, that we are going to use in our backlog population. So impl election scheduler, pop an, what was it? Activate, and let's see, we take an account and a transaction. Let's go to the class and see what it takes. Is the music too loud, or is it annoying? Should I stop it? Hi, Tom. Okay, so it takes an account, reference, and a transaction. So yeah, let's just duplicate this here. So we will take an account as a reference and a transaction. And so in Rust, you have to say it's a din keyword because we don't know the exact type. So this will, what's the term for in Rust for this? Trade object, I think. So this tells us that we have a trade object here. Okay, so what should happen here if we call activate? Oh, so let's import. I'm missing. Okay. We call activate, and we don't want to port the election scheduler right now because it's a lot of code. So here I want to call back into the C++ code. And if we do it like this, we could use the election scheduler. And for the calling back, let's, how could we do this? Well, maybe we skip this callback for now, and maybe we focus on creating the election scheduler in memory whenever in C++, whenever we create the C++ election scheduler. So let's go to the FFI part. FFI stands for Foreign Function Interface. These are is the C API that we use to connect C++ and Rust. And the modules in here are structured in the same way. So let's go to voting and let's add a new file. It's at a good level. Okay. Thanks, Foss. So let's add an elections scheduler here too. And first thing we need is a function that creates an election scheduler. So I have to say no mangle, which means it will use the C ABI and can be called just like a C function. And then we say, no mangle means it should not change the name. And now we say pub extern C, which tells for us to use the C ABI. And I prefix all of the FFI functions with RSN for RS Nano. Election scheduler create. So this function will return, what will it return? I use this pattern almost everywhere now, where I just return a handle, and this handle, we have to define it here. This will be an election scheduler handle. And that's just a wrapper type, just a wrapper containing the actual election scheduler. And we will see soon why I do this. So now we will return that as a raw pointer. So like this. And so we return a box into raw, which converts it into a raw pointer. A box new, which does heap allocate, election scheduler handle, and our election scheduler. So as soon as I save it, I think the header file gets created automatically. So now let's have a look at the C++ header file, which is called rsnano.hpp. And we should find this function in here now. Let's search for election scheduler. Oh, it's not here. Really? No? Okay, then let's build this. Let's build this. No? Okay, there must be a problem then. Why do we need, so we don't need, so this is just for this specific code that I want to port. I want to port the backlog population. And let's just open it up again. Backlog population. So it's a very simple class, and we could port it, but there is this one exception that we just can't port, and this is this line. The backlog population calls scheduler.activate, and the problem is I don't have the election scheduler in Rust. So right now this is something new actually. I don't know if this will work out well. I don't want to port the election scheduler because it's just a huge thing. So what I try to do now is just call back into the C++ election scheduler, and that's why I just want to create this super simple election scheduler in Rust that doesn't do anything but just call back into the C++ code. Does that make sense? Okay. So let's see if the function is in our header file now. Okay. Why doesn't it work? That's strange. What am I missing? Parse an election scheduler create. It's in here. We have it in the mod. Maybe have I saved everything? Yeah, I think this is the curse of the live stream, when things just don't work. Hmm. It's not there. Okay. Oh, huh? Didn't I? Oh, yeah, stupid me. Okay, I didn't add it. I forgot. Election scheduler, the module. So it was not included in the build. So now it should be there. Let's build again. Just stop here. Yeah, finally. Okay. So this was auto-generated. This is the C++ header file, which is for the C API that RS Nano exposes. So now we have this function here. It creates an election scheduler handle pointer, and it's an opaque type. We don't know what's behind that. It's just a pointer. So we are going to use this to, or we're going to call this whenever we create the election scheduler in C++. And let's do this. So where's the election scheduler? Election scheduler HPP. So there's the constructor. So first thing we need is we need a handle. This handle we just created, we need this in here. So let's add it. Rs nano election scheduler handle pointer handle. And let's forward declare this so that the compile times don't get too big. Rs nano election scheduler handle. Okay. And now let's initialize this in the constructor. So we say handle is rs nano rsn election scheduler create. So I think we need to include rs nano HPP. So, okay, first step done. Boss has a question. Yeah, the live demo gods. Running Coder, hi. Big fan of your work, man. Boss, where does the C code live in the project structure? Is everything that isn't ported to Rust yet called through FFIs? Yes. So the project, let's go to GitHub. So the project, this is the GitHub repository, and it looks just like the official Nano node. So I haven't changed that structure. I've just added one more folder, and that folder is Rust. In here in Nano is the usual C++ code base, and in Rust there's the Rust code base, and both are connected via this FFI part. So this FFI module, or I think there's a diagram in here. Yeah. So this FFI module is just a huge collection of C functions that I created, and the C++ and the Rust part, they communicate via the C functions. And I move the C++ code to the Rust side slowly, and the goal is to delete the FFI module, all of it. But yeah, that's a long way in the future, I think. And usually I port from the bottom up, so I look for code that does not have any dependencies, and then I don't have to do what I do now, the callback stuff. But I thought for simplicity of the stream, I would do it this way because I've been working on the confirmation height processor, and this is just a complex thing, and working on a complex class like that in the first live stream, I think that would be too much. How do you track the changes on C++ code that already got ported? Is that automated somehow? Instrus asks. How do you track changes? So you mean changes that the core team makes, I guess. That is done with Git actually, because Rs Nano is a fork. So you can see here it says 1,242 commits ahead and one commit behind. So I know now that I'm one commit behind. That means the official Nano node has one commit more than my code base. So I can just click on the official Nano node and I can just look at the commits there. And this one commit here is the commit that I don't have. So I can just open it up. And sometimes I can just merge it automatically. But if this commit has changes that I has changes at places that I have ported already, then I just have to read through it and have to actually apply the same changes in Rust. And that's a lot of work sometimes. But yeah, I think that just comes with the process. I don't think there's a good way to handle this. Um, it's tracked by line count. Yeah. So, oh yeah, but the line count, I have a small script in here that's called percent Rust, and that does count the C++ lines, the Rust lines, and just outputs the percentage ported. And this is the number that I put into this diagram every month that you see here. So let's let's get on here. So what we did now is we initialized the handle. So now whenever we create an election scheduler in C++, we also create an election scheduler in Rust, and they are connected through this handle. And this is a memory leak now because we create the handle, but we never delete the handle. So the next step would be to delete the handle whenever the election scheduler gets destroyed. So let's create a function for that. So I copy that, and I call this one destroy. And it will take the handle and return nothing. And here we just say drop, which frees the memory, and we convert the raw pointer back into a box. The box from raw does that, and we just take the handle. So, and this is unsafe, so we have to say unsafe. So now we have two functions, one that heap allocates the election scheduler and one that frees the memory again. So let's go back and call the function that deallocates. So we go here in the destructor. Oh, it's frozen? What's going on? C-line doesn't respond anymore. What? That never happened before. Demo gods. Okay, now here we go. As Nano, as an election scheduler destroy, and we pass the handle. Okay, so now we don't have a memory leak. And now for the hard part. Whenever in the Rust code, whenever we call the activate function, we want to call back into the C++ code and call the activate function there. So how could we do this? This is actually not rehearsed. I actually have no idea. Let's see. So we need a callback. We need a callback, and let's call this. Oh, I don't know the syntax. Let's check. Let's look at another place where I did this in the past. Yeah, like this. So we need to define the callback type, and we call this election scheduler activate callback, and this is will be a C function. And what will this C function take? So I think a good solution would be that it would take a pointer to the C++ election scheduler and the arguments. And the arguments are an account. You need a pointer or reference to Nano node. Oh yeah, that's horrible. So usually this cannot be ported like that because Nano node has dependencies to everything. So whenever I encounter something that has a dependency to Nano Node, I first refactor the C++ code part that it does not need a reference to Nano Node. Rust is really bad in circular references, so it has to be hierarchy has to be there, and the back references, they are just very painful. Okay, so an account and a transaction. So how can we pass the account? Um, the account, I usually just pass the account as a pointer, as a byte pointer, and the C++ part will then just read from that byte pointer and copy that into an account instance. And the transaction, I think I have a handle for transactions. Transaction handle. Yeah, let's use a transaction handle. This also has to be a pointer. Does this have to be mutable? Can it be const? Let's try const. If it doesn't work, we'll make it mutable. And it does not return anything. Okay. Oh, I closed it. I didn't want to close that. Let's close the other things. Mod confirmation, right? Let's close that. Let's close that. Okay. And let's open election scheduler again. So this will be our callback. And how did I do it in the logging part? Oh yeah. So I don't know if this is a good way, but it works. And because this is all going to be deleted in the future, I don't care if it's ugly. But I just have a static global state for the callback, and we initialize this from the C++ part. So let's call the static election scheduler activate callback. Activate callback, and this will be an option of election scheduler activate callback. So this is initialized to none, so it's not initialized. This is like a null pointer in C++. So we have to initialize this. And for the initialization, I need also an FFI function. And let's just copy it from here like I did it here. We need a, now that I do this, I think this code example maybe is not easy at all. Yeah. So callback election scheduler activate. And we take this function as an argument. And then we set our static to this function. Does that make sense? So if you guys have any questions or if I'm going too fast, please tell me. Okay, so this new function here, we will call this from the C++ part. And for all callbacks, all callbacks are currently just one file, and that file is called Nano Callbacks, or RSN callbacks. What's the name? Callbacks. Yeah, Nano Callbacks. So this file contains all callbacks, and there's this huge function here, set Nano Callbacks, and this just sets all the callbacks. and it is executed once before the node starts, and it is executed once before the unit tests run. So we can just add it at the bottom. Rs nano, rsn, oh, just copy it. Let's just copy it. Now I see the pain of circular references. Yeah, the pain is in Rust is so much bigger than in C++. In C++ you could do this and not feel the pain, but in Rust it just doesn't work. So here we have to set the callback, and let's call this election scheduler activate. So what the function signature, let's go back to our Nano HPP file and let's have a look at the function signature. This is the callback. Okay, so it's void pointer for the election scheduler pointer, and yeah, like this. So I'm just going to copy that and put it here. Oh, we have to create it first. Election scheduler activate. So let's create that function. Void election scheduler activate. Let's add those arguments, those parameters. So this here will be the scheduler pointer. And this will point to the C++ implementation of the scheduler. This unit 8 pointer is the account. Oh, yeah, let's use the Nano convention. They suffix everything with a, which is an argument. Transaction handle, just txna. And now in here we will just cast the election scheduler pointer into an election scheduler, into a real election scheduler pointer. Election scheduler pointer. Yeah, let's remove the pointer. That's just noisy. Oh, what did I do there? Hey, Colin. Oh, nice that you're here. So we are just trying to create a callback from Rust, a callback to C++ for the election scheduler because I don't have that ported yet. So we are just trying to create an election scheduler in Rust which calls back into the C++ part. And then I can port the election scheduler in the future. There's Nano transaction handle. It is. So where were we? Yeah. So now we did a pointer cast here, a cast here for the election scheduler. And now we can call it activate, and we pass. Oh, okay. We need the account. We need the account, so let's just copy. So when I write all of this glue code, this is the glue code here, I don't worry about performance too much because it will disappear soon. So I just copy stuff a lot, or I heap allocate a lot, and that's okay because it will. So let's create an account. And let's just copy Wait a second. Don't I have helper functions for that? I don't, I think. Okay, so we copy account. So this is also ugly because it's hard coded, but I will just say, how much is it? 32 bytes. And we copy that to our local account variable, like that. And so that would be the account. And the transaction, why is that red? 32 bytes. Thanks, Dimitrios. What's the problem here? There isn't a transaction handle in here, is there? Oh, it's a pointer. Yeah, it is a pointer. Okay. Action handle. Yeah. Oh, okay. It was an IDE issue. Now it's not red. Okay. So, oh, that does not. Oh, account A. Transaction handle. So what could we do here? The transaction handle. We need a transaction. Let's have a look at the class. Is there an LMDB? No, what was it? Transaction. Let's check where transaction handle is being used. No, wrong key combination. Like that. Oh, I have to define. Do I have to give the concrete type? Oh, that's bad. I don't know the concrete type. I don't know whether it's a read transaction or a read write transaction. Oh, I'm in trouble. Do I have anything here? No. Check action signature. Is it a reference? Check action signature. Is it a reference? You mean in the class here? Yeah, it is. It is an. But the problem is I have a transaction handle, which is a Rust point or just a raw pointer or a pointer to the Rust implementation, and I have to convert it into a Nano transaction. So I have to instantiate either a read transaction or a read write transaction, I think. Or do you have a simpler solution? Because this is the read transaction. This is the write transaction, MDB. I've never done that before in the code base, so nah, I shouldn't have done. Yeah, I shouldn't have done something extreme that I've never done before. Mm, so I could ask. Yeah, that's a hacky way, but maybe for the stream it would work. Mm. Oh, the music did stop. I want to let's stop the music. I think that's too much for my weak internet. Um, yeah, yeah. Let's just cheat here, and I'm going to add. It's getting exciting. Yeah. So I'm going to be I'm going to do something dirty here. I'm going to add a function to the transaction where I can just ask what it is. Yeah, let's do that. Or do you guys have a better idea? Can you create read or write transactions anywhere? So what I want to do is I want to I just want to have a wrapper. I don't want to actually create a transaction because the transaction we already have the transaction. Yeah, wrapper. Yeah, you're right. Let's create a wrapper because the transactions are actually pretty simple, I think. Well, let's check the transaction interface. Yeah, a wrapper would be much simpler. Thanks. Yeah. Um, oh, it doesn't do anything actually. It's just it just has the it doesn't do anything in here. I'm not sure if this is the same as in the Rust in the original code base because I know I did a lot of changes in here, but it just does nothing. So yeah, let's create a wrapper. Transaction wrapper. Um, this will just take the handle. Handle. And I just I'm just too lazy now to move this to the CPP file. Let's just uh, initialize it in here. And this will then just have the handle here as nano. Let's copy it. Handle, handle, handle. And then we need this function. Oh, and it has to be a transaction. And oh, I'm really not fluent in C++. I have to look it up. How do you override? Do you override? No, it's here. Uh, Override like this. Let's try. And this will just return the handle, and this should solve the problem. Let's see. Transaction wrapper. Um, no, callbacks. Where are the callbacks? Callbacks here. So let's use that one here. Nano transaction wrapper, tx and wrapper, and we initialize it with txna. And we don't have to delete the transaction handle. Um, yeah, we don't have to. Hey, Vinny, how are you? Nice to see you here. I don't really understand what you're doing. Yeah, but I like to see you do it anyway. Thanks, man. Very excited with RS Nano, and I think this live form is great for community involvement. Cheers. Yeah, I had this idea of doing a live stream because I love to watch development live streams myself. So yeah, nice to hear that you guys enjoy it. And yeah, so this example is way more complex than I hoped it would be. But yeah, as I said, the problem is all the simple parts are ported already. So what's left is not that simple anymore. Um, okay, so we have the wrapper. Now let's pass the transaction wrapper. And let's hope that this works. What's wrong here? Is that actually a problem? Okay, we will find out. So that's it. Now this is the callback function. The daily trader says, like Vinny, I just wanted to pop in and say this is all really cool to see. Super over my head, but thanks for all you do. Thanks, man. Yeah, of course, it looks complicated if you see it for the first time, but it's not that complicated once you get used to it. I actually had a lot of trouble learning Rust because I came from a garbage collected language and from C Sharp actually, and yeah, it was difficult for me in the beginning, but now I love it, or I loved it uh, from the beginning, but now it's a lot easier. Um, okay, so let's see if this works. We have the callback here. We set the callback down there, which just gives this function pointer to Rust. In Rust, we store the function pointer in a global state. And now we can call this. We can't call this yet because Foss says, I'm a little lost on the details, but I think I follow along for the most part. Excited to watch your other videos afterwards and learn more. Oh, thanks, man. Yeah, the other videos are very basic. They just show how to clone the repository and how to build the project. Um, I have to move this static here to, yeah, this is ugly, but I have to do this. I have to move these two lines out of the FFI part because let's show in here. So where's no, back, and let's go to Rust folder. So these callback statics are now in the FFI module, as you see this box here, and we want to use it in the node module, but as you see, the node module does not have any references to the FFI module. So this is also ugly, but I'm okay because it is temporary. We move the static and the callback signature declaration to the node module so that we can use it in there. So let's do that. So let's remove it here and move it to where we have the election scheduler. And yeah, we have to add the import for cvoid, which is just a void pointer in transaction. Oh no, transaction handle. Or I don't want to move the transaction handle here. Okay, so I just changed that also into a void pointer because no, that won't work. Or will it work? Let's see how the transaction is implemented here. Transaction. looks like this. And how does the transaction handle look like? Looks like this. Transaction type. What is transaction type? Okay, I'm in trouble again. Hmm. Okay, let's read the comments. Maybe we have an idea. Really nice that you're doing this. Hope this will be a recurring thing. Yeah, I think it will because I didn't know if any if people were interested in this, but it says 8 viewers. That's a lot more than I hoped for. So yeah, I will be doing this again. Um, Transaction type. Hmm. So what to do now? Dimitrios, should you take time to do this well and then do another session to show the final result? Uh, yeah, yeah, hmm, maybe. Can the transaction pointer be referenced from Rust? If there's a C++ function that takes a reference on the C++ side, you can take a pointer and pass to the version that takes a reference. Um, well, uh, it takes a reference on the C++ side. You can take a pointer and pass to the version that takes a reference. I'm not sure I understand this. Um, so the transactions, I ported all of the transaction stuff already. So transactions live in Rust. So they are heap allocated in Rust, and in C++, we have nothing more than just the Rust pointer. How do you handle other function that takes references? Um, well, taking references, usually I just heap allocate everything in Rust, and I have handles in C++, and then I can just use these handles and whenever I need to call a Rust function, and I can just pass these handles in, and that's super simple. So there's not much going on there. The problem that I'm having right now is I want to, yeah, I've never done that before. That's the problem. Um, I want to call back to the C++ part, and I have a transaction here which lives in Rust space. So I have to convert this into something that I can use from C++. And that is a transaction handle. That is a transaction handle. And transaction handle lives in the FFI crate. And here I'm in the node crate, and yeah, I don't have access to the FFI crate from the node crate. So I could move all of that code from the FFI crate to to the node crate, and that would be super dirty because it doesn't belong there. Hmm. What else could I do? Another option. What do you guys think of this? And this is even uglier. I could do this with a double callback, something like this. I could have a callback here, and I could register that a callback in the FFI crate that would just translate a transaction into a transaction handle. Normally, we create transactions as a method on Nano Store begin transaction write. Yeah, and that begin transaction write is already in Rust. So there's nothing left in the C++ part for the transactions. Charterino, hey, would you mind buying a proper microphone instead of your, yeah. Yeah, it's bad, is it? Isn't it? Can you call methods on Nano Store? Uh, yeah, with call, you mean in the C++ Nano Store? I would have to use a callback for this too. So you mean calling Nano Store from Rust, the C++ Nano Store from Rust? Then you get a pointer. Do you know a way to convert from pointer to reference? Uh, no, I don't. Hmm. I think the quickest way would be to actually have a callback for a callback. And this is so ugly. What do you guys think of it? Let me sketch this. So this would go back to the FFI crate, and and we would have another callback, and that callback would not be a C function. That would just be a function that takes uh, a void pointer, an account reference, and a transaction reference, like that. And in the FFI crate, we would provide this callback, and it would just translate this signature to this signature. Is that stupid? I don't know. Is that over-engineered? Is there a simpler solution? Hmm. Let's try. We have to we have to go on like this. We are an hour in already. I hope to actually port that class, but I think we can forget that already. Um, yeah, let's call this FFI callback. Oh no, I don't want to. Lee Boosfield says, I just joined, but you can convert a pointer to reference with just, yeah, assuming you're in unsafe block where you can dereference pointers. Yeah, yes. The problem is that the types are different. So I need a nano transaction pointer or a nano transaction reference here. Let's go to activate. So I need this here. I need a nano transaction reference. But what I have is nano transaction handle. And transaction handle comes from Rust and is just an opaque type. It's just a pointer to inside the Rust stuff. And they are not convertible into each other. So that's the pain right now here. I want to try this. I don't know if this will work out. So let's move this back to the callbacks back to here. And in here, how can I call that? I want to give this a different name so that I'm not confused later on. Ah, cool. I didn't realize you meant C++ references. Okay. Election scheduler, activate callback. What would be a better name? Naming is hard. Mm. And we would need a static here too. Let's call this Let's call this connection scheduler activate callback, or let's call this, I don't know, internal callback, for the lack of a better name. And down here, we could then just use that. So we could say election schedule expect. So expect would fail with an error message if it is null or none. In Rust, it's called none. So let's just say not defined. Oh, yeah, something like that. So this gives us the callback. And like that. And this is unsafe. Yeah, so accessing static is unsafe, like that. And does this work? Unknown. Why is this unknown? How is it done here? Oh, it's okay. It's with a match. I've done this with accept, haven't I? Oh, there's a problem up here. Election schedule activate callback. Oh, it's an internal callback. Yeah, now it works. So it says callback is an fn, void public key, and so on. So now we could just call the callback, and yeah. So okay, the pointer. We need the C++ pointer. And we need the count, and we need the transaction. So this C++ pointer, we don't have that yet. That's the next step. We can ignore this for now. Let's just say the pointer is default. Is there a default for yes to do? No, there's no default. Returns default. There's no default for. Oh, how to create a null pointer? Oh, like pointer null mute like this. So we just set it to null pointer for now because this problem is we will handle this problem later. And now let's go to the FFI part and let's change this. So let's initialize our internal callback. Oh, is it public? It is public, and we have to say pub use election scheduler callback and the type definition also. Okay, so now we can use it in the FFI crate. And let's set it here to election internal callback is some. And what is the function? The function is, we need a name for this, forward scheduler activate, I don't know, activate. Dimitri says, would it be simpler to port Nano election schedule activate into Rust? Yeah, so this would be my usual way of working. I would just find classes that don't have dependencies because callbacks are really painful. And but I couldn't find a simple class for the stream. And I thought it would be simple. And So this is the programmer's course. Have you heard that one? I read that one recently. It says we do these things not because they are easy, because we thought they were they were gonna be. Yeah, I thought it would be easy, but I was wrong. Um, I'm sorry that this stream is now so complicated. It just check, look into the ledger to find the first unconfirmed blocks and push into the. Yeah, but the problem is I don't have any of the dependencies. I don't have the active election container. I have nothing of that. So a good way would be to just see which class does not have any dependencies that are imported yet and start there. And I just couldn't find a class that was simple. So I thought I would try something new and I would just add a callback, but this adding a callback turns out to be hard. Oh, you mean just a single function? Yeah, yeah, that would have been a better idea, maybe. Yeah, yeah, definitely. If forward schedule activate is going to call election schedule activate callback, you could consider just creating a closure to call it and putting that closure in the internal callback variable. Um, yeah, you're right. That would be a good idea. Let's try. But I'm probably missing context here. It says most of the activate function does not do activate work. I don't I don't know. I haven't looked at it really. I want to see. Um, what does it do? Yeah, so store would not be a problem. I've ported store already. I've ported ledger already. What is priority? What is this? I cannot see. I think this is ported already. Yeah. Oh, yeah. It doesn't do much. Huh. Priority is queue. Yeah, priority is, I ported that already. Mere text thread. Oh, yeah. Now that I think about it, it would have been better to port election scheduler. Yeah, it doesn't do much. What is this? Active? Active transactions. Yeah, this I haven't ported. Active transactions. Okay, yeah, let's get on with the work. So I want to try what Lee, what's how do you pronounce that name? Boosfield said. Just a closure in the internal callback. Let's see if that works. So, no, closures. Closures are, it doesn't work because for a closure you would need to heap allocate and you would need to have a trait object. Is it? Yeah, I think trait object for FN. I'm not sure if this would work. It could be a box. Then it could be, yeah, I don't know. I want to do this in this way, and it's a stupid way, and I want to delete this code as soon as I can. And maybe there's a way to do this with closures, but I think you would need to heap allocate there, and I'm not sure how to do this. A move closure that captures, right? Yeah, but a move closure that captures would still need to be a box FN. Okay, let's try. Let's try. Um, then this here this would have to be a box fn, a box fn with this function. Um, okay, let me do it in this way first because I'm getting this too many things in my head now. I want to do this in the stupid way first, and then we can think of moving it into a closure. Um, Forward schedule. I have not uh, defined that yet. So fn forward schedule activate, and this has to have which signature this. So this has to have this signature. Oh, so we have the CPP scheduler handle a pointer, or CPP is a void pointer account, and we have the transaction here. And in here, we would just call this callback then. And this now takes the CPP scheduler pointer, and it takes a byte pointer for the account. So this would be account as bytes. As pointer. And oh, there's new stuff in chat. Oh, a lot of stuff in chat. Then it's a trade, right? Well, there's if you the small written fn is not a trade, so there's a difference in so fn whatever. This in small caps written fn is not a trade, so this is just a function pointer, and there's the capital Fn, which is a trade and requires a trade object. Um, Hey, Tiago, nice to see you. Hey, Gustav, thank you for letting us watch a bit the implementation from Rust perspective. Feeling that I need to learn Rust soon. Yeah, it's a great journey learning Rust. Fn with a capital F is yeah is a trade, but Fn with lowercase is not. Yeah. Okay. So where was I? This is account and transaction. And now for the difficult part, we have to convert our Rust transaction into a transaction handle. And transaction into a transaction handle. So into raw box new transaction handle and transaction type. Oh, this new returns a raw pointer already. Okay, let's let's change the code accordingly. So it has a new and it takes a transaction type. Is that not public? Is that not exported? Transaction type? Action type. Okay. Let's find transaction type. It is in mod rs lmdb. Maybe I have to yeah, I have to make it public. Okay, I think that did the trick. Transaction type. Yes, there it is. So read, ref, write. So it has to be an LMDB read transaction. Oh, it takes ownership. No, it didn't read transaction. Read ref. I'm getting from one trouble into the next. So the only value here that supports references is the read ref. Okay, guys, this is now really getting really complicated. What's the overall objective of this dev work? You mean what's the overall objective of Ars Nano? That would be to port the Nano node to Rust. And the objective of this stream was to port this small little class called, what was the name? Backlog population to Rust. And I got myself into a lot of trouble and I haven't even started touching the class. So, and the stream is, yeah, almost over. And it's actually, I find it very difficult to talk and to write code at the same time, to be honest. So let's, what to do here? This only static, then read transaction. I don't have a read transaction, I just have a transaction. But it is a read. Who is responsible for starting the transaction? Does the election scheduler use write transactions? I don't think so. Does anyone of you know? Does the election scheduler use? Is it used in write transactions or is it only being used in read transactions? Activate. It's a read transaction. Thanks, Dimitrios. So we're going to do something even more ugly now. We will just assume that it is a read transaction and cast it into a read transaction. And it's created in backlog propagation class. Oh, okay. Okay. It is only used to find the block to push to the active election container. Okay, let's see if we can cast this into. So we have the transaction. What does transaction have? I do have an SNE, and that's good because I can use this to cast it to whatever I want, so like a read transaction. Okay, let's see. Transaction as any. How to cast from the any type, I don't know. Let's go to here. Let's Google that. Cast any. Trades. Any. Downcast ref. Yeah. Return some reference in a value. If it's of type T or none if it isn't. Let's try this. Downcast ref. And we want to cast it to read. Oh, what's happened here? We want to cast it to a read transaction. Okay, so this is unsafe. What else? So now transaction handle is, I think this could work. Force says live coding is really difficult, honestly. I used to live stream some game dev, really work, and it was hard to get anything done. All of the props to you. Oh yeah, thanks. I find it really difficult because I'm just not used to talking while thinking about code, and yeah, and now I got myself into complicated trouble. Um, so I don't have errors here. So let's see if this works. Um, the only I hope this works. So the only thing missing now is the CPP pointer. So the actual pointer back to the C++ code base, to the actual election scheduler. So we need this, and we need this as a field. So I call this just CPP election scheduler. Is just a void pointer, and we have to initialize this in the constructor, and then we can use that one down here in as self.cpp election scheduler. So that should lead us to, this is not an error actually. This was related to what I did this morning. There's something wrong with the caches here, so I have to trigger a recompile and the errors go away. So okay, here we have an error, election scheduler. It cannot find election scheduler. Change visibility. Oh, it's not public. It is public, is it not? Election scheduler. Now we can use it. Okay. What else? cvoid. We have to include import cvoid. What else? Oh yeah, we have this now requires us to pass in the CPP election scheduler pointer. Live stream code is tough, but thanks for sharing your work. Yeah, thanks, man. I don't think the code is compiling as downcast ref returns an option. Oh, you're right. Where was that? You're right, the downcast ref returns an option. Let's fix that. Downcast, where's the downcast ref? Why doesn't it? Let's just unwrap this. And this should then return the correct type. Why doesn't the compiler say that there's an error here? So this is just really ugly and it could crash, but retransaction, then does this work? So many errors. So here we have to pass the CPP elections scheduler pointer here, and we have to take that as an argument here. Scheduler C void. And another problem here. Yeah, what's the problem? The size cannot be noted. Compilation time. Oh, I cannot downcast to trades. Is that right? I have to downcast. I'm in new man's land. I've not worked with downcasting a lot. Yeah, I'm not sure you can downcast a din into another din. Converted the din into the any type here, then I downcast to the inner value if it is of type T or none if it isn't. Yeah, I think I have to use the real. But I know what type of transaction it is. I know it is a LMDB retransaction. So that should work. And an LMDB retransaction is a retransaction. Lifetime. Oh yeah, I know that this would come, the lifetime issue. And now it's getting even worse. I have to say I have to just hack the lifetimes away. And I have to transmute this into what's the syntax of transmute? Probably can't make a V table for another dim, but I didn't know enough. Yeah. Oh yeah, that works. Only thing left is the lifetime. Yeah. So let's just transmute and let's just get rid of the lifetime. And this is just really unsafe. But I want, just for the sake of the stream, I want to see if we can get this to compile before the stream ends. So what does this return? I want to transmute. This is an LMDB read transaction reference. And I want to transmute this into a static lifetime reference. And this is super unsafe, and I don't even know if this will work. Okay, we don't have, oh, no, we do have errors. Call to unsafe function is unsafe and requires unsafe function or block. What is unsafe? Oh, this is an unsafe function. Yes, this is unsafe too. Okay, we got rid of all the errors. And um, let's see what happens now. I get my guess is it crashes. So whenever I do so much unsafe stuff, it's I think it will crash, but we will see. Um, so the Rust part doesn't have any errors now. The only thing missing is in the C++ part. Oh, there's the class keyword missing. The only thing missing in the C++ part is in the constructor. We have to now pass the pointer to itself. Does this work? I'm not sure. Can we just say this? Is this initialized in the constructor? Let's see. Let's compile and let's see. And if this works, I'm going to end the stream because it won't get better than this. Yeah, compilation takes forever. And that's my biggest pain point with working with Nano. And it's not all Nano's fault actually, because it's also the fault that the RS Nano HPP file, the FFI header file, um, that's used everywhere, and that means just I have to recompile the whole project, and that's, yeah, not a good thing. So we have what's wrong here. Transaction wrapper does not have any field named handle. It does. There must be something wrong here. Oh, there's this missing. Was that it? Uh, Term factor, but it might make sense for transaction handle to have a lifetime. Yeah. Uh, well, the problem is transaction handle is just a raw pointer that we pass to C++. So lifetimes would get lost there. Um, C++ constructors know where they are constructing to. That's why move constructors exist versus Rust, where you can freely move without calling any code. Yeah. I had to get used to the move constructors. That was a new concept to me when I learned C++. Okay, still compiling. So guys, what do you think? Will this work? Will this crash? Oh, we don't even know if this crashes because we never call activate. Oh, that's too bad. We never call our function. Can we call it somehow? I think we can. Let's call it from, let's go to our backlog population class down here. And instead of calling scheduler.activate, let's call our Rust function. Um, Lee says, yeah, they're a pain. I really hate the rule of five. What's the rule of five? It just adds so much boilerplate to anything doing. How do you pronounce Rai? R-A-I-I? Rai? Ray? Uh, Election scheduler. No. uh, we let's create another. Let's stop the build, and this will be the last thing we do. Let's add a function to our to our, oh, we don't have that. I know, we can do this. RSN election scheduler activate. No, do we have that? We have a destroy create. Yeah, RSN. No, that's a callback. We don't. So let's create that. Let's create a function and we call this RSN election scheduler activate. And this will just call activate, and it takes an account as a byte pointer and a transaction as a transaction handler. And from here we say handle dot zero, which is the election scheduler dot activate, and then we create the account from the pointer, and we pass in as transaction. So what this does, this is super complicated. What this does now, it calls the activate in our Rust election scheduler, and that would trigger a callback into the C++ election scheduler and would call activate there. Let's see. RSN election scheduler activate. This would need the handle scheduler handle. Oh, I think I made it private. Let's make it public. And here, sorry. Election activate. So we have the handle. We need the account. And we need the transaction. What is the type? It's a shared pointer, isn't it? Doesn't show. I think like this, get Rust handle. And now let's comment this out and let's build. So compiling. Okay, now let's wait and see. I'm really sorry, guys, that this stream is so complex. I thought I would just port a simple class, and now we are in this huge mess. So for the next live stream, I'm going to plan what I want to do, and maybe I'm going to, yeah, maybe I will just try the refactoring before I stream, just to not get into trouble. Because this is, yeah, I think you guys are maybe shocked about what's going on here. So building, building, building. So while it's building, do you have any questions or any ideas or suggestions? Maybe you have better ideas to solve this. Everyday life of a programmer. Yeah, you're right. Exynos said that. Yeah. Yeah, it happens to me all the time. I think, oh, this is going to be easy. And then hours later, yeah, yeah, it's all good. It's definitely complex to have two different code bases working so tightly together. Yeah, that's right. I've never done a partial rewrite to Rust like this before, sadly. And That action hero says, I think it's interesting to see you searching for solutions. Yeah, because I'm the one in trouble. Yeah. Yeah, but that's what I like. I like watching code streams or developers that work live, and exactly for that, because I learn a lot from watching others. By the way, if you want to watch others, check out James Shore. He's my all-time favorite streamer, and he has some really good live streams. Oh, and we've got an error. Variable type transaction wrapper is an abstract class. Is it? Why doesn't that work? Transaction wrapper. Abstract class. Uh, why is it an abstract class? Demetrius, how do you spell him? Oh, James Shore. It is like, let's go to his website, jamesshore.com. And he wrote that book here, Agile Development. It's a really, really good book. And he's advocating agile software development like the old way, the extreme programming way with, and he does test-driven development, and he's really, really good at it. And yeah, he has some live streams on his site, and yeah, I love them. And whenever he live streams, I watch it. So let's, what's wrong here? Why does it say, huh? Where's the error? Here. Invalid conversion. There's multiple errors. Invalid conversion from const transaction handle to transaction handle. Okay, so it can't be const. So let's remove the const. And let's remove, oh no, then I have to recompile again. Let's make this mute. Oh, is this the one? No, not this one. Uh, not this one. Where was the constant mute? This was the election scheduler activate. Um, no, this is the internal callback. This has to be mute. And what's wrong here? Invalid use of incomplete type election scheduler. Oh, I have to include the, that's why. Okay. Where's the election scheduler? Is it in election scheduler CPP? So let's include the election scheduler HPP and build again. Are you self-employed or do you work in a company? I'm self-employed. I I'm a freelancer and I've been working like that for uh, 11 years now, I think. And most of my career was C# development, and I I encountered Rust in 2018, and I fell in love with it. But I had no use for it because all my clients, they were .NET shops, and yeah, so I used it in my free time for my hobby projects, and then I made one bigger Rust project for a client, and then I decided to port Nano to Rust, and and now now Rust. So Rust is has lots of things to learn. Building, building, building. So if I could improve one thing for Nano, it would be the build time. It wastes so much time having to wait for the build and running the tests. The tests are also pretty slow because usually I work in much smaller steps, and I build a lot and I run the tests a lot, and yeah, that makes it really painful. Bob says, "Oh, Bob, is it you? Hi, nice to see you. Thanks for doing this live stream. What's your plan for the FFI part? You said it would go away soon. At what point can it go away?" So it will not. It will go away gradually because it will go away gradually. So whenever there is enough ported to Rust that the C++ part can be deleted, I can also then delete the FFI bindings. Demetrius says, that's why I bought an Apple M1 laptop. Yeah, I should buy a faster laptop too. Lee says, I'm not sure if it would help here if the header file really is changing, but Zcash has helped me in a lot of similar scenarios. What is Zcash? I'm not a C++ dev, so there's a lot I can learn there still. Um, what is Zcash? Compiler cache. Yeah, I think the main problem here is I have this file, and this is my fault, rs nano hpp with all of the foreign functions in there, and this is referenced by almost all of the C++ code now. So that means whenever I make a change in the FFI part, this header file changes, and then all of Nano has to be recompiled. And yeah, in the beginning that was not an issue because it was just being used by a couple of classes, but now it's almost used everywhere. And I don't know if how to make this better, and I don't even know if it's worth making that better because the C++ code, yeah, shrinks, and all of that glue code is I consider that to be just yeah, temporary. Or, I don't know. Do you have good ideas how I could speed this up? Would Zcash help here because this header file actually changes? Zcash avoid unnecessary compilations, says Dimitrios. But yeah, I think the problem is this header file actually changes. So huh, Mac uses Zcash automatically. All you have to do is install it. Okay. All you have to do is install it. Do I have it? No, I don't think so. No. Compiler cache that speeds up recompilation by caching previous compilations. Okay. I'm going to look into this. Yeah, I'm on Arch Linux. So I spent 2 hours trying to port a class, and I have not even touched the class. Almost done, guys. Almost there. Linking. Demetrius says, if anyone asks me what do I do at work on my daily basis, I just point them at this video. Yeah, yeah, that's yuck shaving at its best. Done. It's done. Okay, so let's run the tests. What do you guys think? I think it will crash. Um, let's make build debug core test. So let's be optimistic, and while the test run, let's reformat the code. So that's if you want to help with this project, that's something you should always do. There's two scripts. The one that is in the original Nano node in the CI folder, it's called cargo format do. That does no, sorry, cargo format do. I added that. This is for Rust, and for the C++ part, it's clang format do, and that reformats all of the C++ code. Yeah, lots of changes here. Yeah. Still no test failures and still no crashes. How do you know your code is being used? It's being used because added, I went into the backlog population class. I commented out the scheduler.activate, and instead I called into Rust here, and I said scheduler activate there, and this would call back into the C++ part and call activate, schedule activate there. Let's hope that there are unit tests here. Let's see if there are no unit tests for backlog population, but there are. Let's see. Backlog population, who uses it? Hmm, nothing. So maybe, I don't know, is this tested? Backlog. RPC populate backlog test. Yeah, I'm not. Okay, I won't. I'm going to create a branch for this because I want to make sure that this actually works. And I won't. I'm not going to do this today, but tomorrow. So let's create a new branch, and I call this uh, election scheduler activate callback, and I'm going to push it there. Add callback, add Rust callback. No, add election scheduler activate. Yeah, whatever. So I've just pushed it to GitHub. So if you guys wanna have a look at all of the changes we made, um, you can just check out this branch on GitHub. Let's go here. Here it is. Here it is. Yeah, so you can just check it out here. Test still running. Yeah, so I think that's it for the stream. Again, sorry that this ended like this, and we didn't actually port anything, but just added a callback into ours. Hope you guys had fun. I definitely had fun. Um, we don't have a unit test, but almost Piotr, is that you, Piotr? Hey, I recognize you. But almost all of tests use backlog population, so it must be working. Oh, that's good news, Piotr. That's good news. Yeah, then I'm going to clean this up tomorrow, and maybe I find some workaround for all this unsafe stuff. And yeah, let's call this a day. I'm really happy that we actually reached a state where it worked. Yeah. So thank you guys. Thanks for watching, and until next time. Bye.